Hello and welcome, and thank you for coming today. So Grace and I are going to give a webinar based around a concept that we've been building on for a while, which is around interoperability of tools and trying to sweat the assets and try and build these symbiotic relationships. But one really important aspect is, well, that's all good and well, but what kind of interoperability should I be looking for? What's the so what behind trying to build these symbiotic relationships? So another element we looked at is creating a cloud strategy with a security strategy. So we're going to touch upon elements of that today. So let's begin. So what to expect from the webinar? So who and what are Summerford associates? So we'll give a brief overview of who we are and what we do. We'll have a quick look at a cloud strategy concept that we've conceived, which we call the 3 Vs. We'll have a look at some of the overviews of the technologies involved as well. So specifically, we'll have a look at Splunk, Okta, Netskope, and Terraform. But really, we're looking at those particular capabilities, but we'll look at the general capabilities as well. We'll also have a look at demystifying the technologies and how we do this is by providing practical examples. So it's all good and well having a CASB, it's all very good well having various different IAM solutions and data from anywhere platforms, but what are the actual use cases? How can we understand and define them practically? So we have a look at a couple of practical examples of how we do this and how we interleave the various different capabilities of each platform into one another. And then we'll have a summary, and if there's any questions, we can take some questions as well. So who is Summerford? So before we start, who is Summerford? I suppose we should start with who we are. So my name is Baz Donoghue. I'm a solutions consultant here at Summerford Associates. I've been with Summerford, I think, around 3 years now. And prior to that, I spent 12 years in the Royal Air Force as a Trade Group 4, so comms technician. And I spent 6 of those years at the Joint Cyber Unit at MOD Caution. So I got to get to grips with various different types of technologies and how they integrate, but not just the technologies themselves, but the people and process elements that need to go behind those as well. Grace?
So obviously you've given a great intro into who Summerford are, and I just really wanted to extend upon that in regards to our kind of focus areas, which of course is people on this call today, our customers and potentials, our products that Baz will take you through later on, and obviously the interoperability, which is definitely a mouthful for me on a Monday, between them. And the bit that I really wanted to focus on is the people, because without our amazing engineers, our incredible professional services team, pre-sales teams, and support teams, we wouldn't be able to offer such a robust and kind of widely available cross-platform support and, of course, deployment. Now, here at Summerford, we have dedicated project management, and they will obviously make sure that your project works 100%, goes without any problems, and every time kind of period is met or any milestone is met along that journey. They'll also make sure that if any prereqs are needed, that they'll be covered off so that on day one you can get started and just kind of move forward. And we also run a lot of enablement workshops and training sessions as well, which allow you to get hands-on with these softwares. And also we will help to implement, obviously, interoperability between them in those sessions. If it's on, say, Splunk and Okta or Okta and Netskope, things like that. And of course, we can obviously help you through our professional services team as well, who are undoubtedly, as Baz is part of them, some of the best in their field, and have been relied upon for delivering small customers deployments. The smaller customers, 1 to 5 people, right the way up to some of the largest organisations in the UK. Now, we also have a whole host of government SC cleared staff as well. So if you do need any government specialists or anybody with clearance, we can also provide that. And after the sale, we can always support you and make sure that long term you're getting the value and the delivery that you need out of the investment that you've made with our dedicated in-house support desk who resolve. It says 80% on the slide, it's actually 95% currently of support cases are resolved without the need for any escalation to our vendors, which also means that we resolve them in a much quicker time period than, say, the vendor SLAs, because we have a more kind of flexible team, and we always have engineers available for support, rather than obviously the vendors who are a little bit more kind of tied on how many people they have and also the number of customers as well.
Okay, so let's jump into the cloud strategy then. So the 3 V's, as we mentioned them. So those V's are vision, visibility, and value. So I'll go into explaining these only briefly. They're pretty huge topics in and themselves, cloud strategy being an absolutely massive topic. But these are some of the things that we've encountered when we've been talking to customers. We've been engaged by customers with regards to all the various different technologies, capabilities, and strategies that you can use to manage and secure cloud environments, be this infrastructure as a service, whether or not it's software as a service, and all the myriad of various different acronyms in between. Very often organizations have a really good grip on static infrastructure and how to secure static infrastructure. But when you try to translate the policies typically and the strategies and security controls from static infrastructure across into an extremely elastic dynamic infrastructure in cloud, they very often don't marry, and so often they seek some guidance on areas that they should be concentrating on, what it is that they really need to focus on from a capability perspective, and what it is they need those capabilities to do. So we've kind of developed this through conversations with them to kind of be, a bit of a guide essentially as to things that we could look into. So firstly, vision. Okay, so this is typified as exploring the benefits of rationalizing and articulating the cloud security strategy for an organization. So it's having a look inward and trying to really get to grips with, well, what it is that we actually need to do. So the question is, might well be, well, what is the focus of our cloud security strategy? Which if we put in simple terms, or what are the cloud security crocodiles nearest to the canoe? Are we really worried about DLP, for example, or is remote working and access around that, and the VPN structure and how to monitor and apply system controls to that element? Is that really a focus of ours? And try and understand exactly what those are. So as I said, the answer to these are, for example, might be, okay, so managing data loss prevention governance on cloud technologies. This might be well be a staple line used across various different cloud strategy policies. But again, what does it actually mean? So this really means, how do we ensure our data doesn't end up where we don't want it to? And not only that, how do we prove that this is happening? Because everything ultimately needs to be auditable. But also, this is going to lead us back into one of the other V's, which is, well, if we can't prove that we're doing it, and we can't prove that we're doing it effectively, we can't ever improve, because we don't have any understanding of the current value, and then we can't garner whether or not we're getting value from our tools and technologies and the approach that we're leveraging for this. This then leads us on to visibility. So again, this is then once we kind of rationalized our vision and we kind of have a bit of better understanding of what our vision is going to be from a cloud strategy perspective, we're going to need to have visibility. And what we need to understand is the required level of platform and product visibility required to realize that rationalized strategy. So if we do, if DLP is a concern for us, so if we really are concerned about users who are working remotely, they have access to various different SaaS platforms, maybe the various different cloud storage elements, and we're working with some sensitive data, whether or not that's IP, or whether or not that's GDPR related data, for example, or personally identifiable information. We want to make sure that we have control of that and we understand where it is at all times. And if it's being attempted to be placed or even placed into SaaS applications that are ungoverned and not part of our strategy, we need to be aware of that. And if we don't have visibility of that, then it is impossible for us to apply security controls against that. So again, how do we develop? A question may well be, if we're having a look at the visibility step, is, well, how do we develop and maintain security controls on a public cloud infrastructure? Quite a broad question. But really what we mean is, we want to be securing dynamic operations and development environments, or are we creating secure products and deliverables? So this is a question around kind of DevOps and Sec DevOps, for example, whereby there are arguments where in DevOps and Sec DevOps, where we're creating an environment whereby we're then developing a product. Well, is that a product that we deliver? So is it some code? Is it some software that we build out and we deliver to customers, and we require that particular product to be secure? Or are we developing pretty much anything else? Are we developing a platform that our users are going to use internally? Are we developing a web platform maybe that our customers interact with, maybe a cloud application that our customers are going to interact with and not actually own the code, but they interact with it? Well, are we developing that in a secure way? Do we want to secure that? Because that's, again, subtly quite a different concept. And one of the answers might be, well, actually, we may need to leverage Elastic PAM. What's Elastic PAM? Well, can our privileged access control scale with the dynamic infrastructure? Are we working with developers or against them? So in this instance, we're going to talk about an example of this, but there is a problem space where the cloud environment, certainly in IaaS environments now, is so ephemeral, so elastic, and almost non-human interactive when we start to look at features such as infrastructure as code. How can we be sure that any privileged access that is configured as part of this ever-expanding pool of resources that we have is always kept on top of, so that there aren't ever loopholes that can then be leveraged by threat actors on what are dev environments, but actually within a dev environment, they tend to be lots of privileged users. Typically, lots of organizations use the same sort of username, so the default admin, etc. And again, if this is exposed, which again, if the organization doesn't have a huge amount of exposure to IaaS platforms previously, they might not understand where that exposure might come from. Then when it does get exposed, it's all the more troublesome. And then finally, value. So this is, again, from what we've discussed, is appreciate what value is being provided and how to improve that value through cumulative capability and leverage interoperability to ensure measurable outcomes. So a bit of a mouthful, but really what it means is we need to be able to show that whatever products that we have in place to match the visibility and ensure that the controls meet our vision are providing us with value. And in order to achieve that value, we may well need to have environments where our platforms are configured to be interoperable. What does this mean? Basically, it means, well, I like to use the term cumulative capability. So if we have lots of siloed capabilities and they're each kind of doing whatever their task is from a security control perspective, or maybe security monitoring or carrying out some sort of role, we look for a way to try and interleave these to build up some sort of relationship between them, so that although individually they're very strong, but if we configure them to be able to talk internally with each other and have this symbiotic relationship, then they're going to be so much more powerful, and that's going to create much more value and provide us exactly what we need to do. So one of the questions here is, what is the focus of the cloud security strategy? That we've had a look at as part of the vision, and is this achievable today? And if not, then why? And then how do we prove that we're doing it? So really being able to have that line in the sand to understand, okay, well, what is it we want to do and why aren't we doing it now, and how do we get to that place, will help us understand whether or not the tools we have incumbent are going to be working for us and work towards that vision, or whether or not they don't play a part in that vision, and therefore we may be able to save value by utilizing some other capability that does meet our current vision. Yeah, and this is all around understanding cloud capabilities to leverage cumulative gain. So where are the gaps in our current cloud security capabilities? And do we actually already have a solution in-house that might be able to plug that gap? So we might not need a new capability. We may have a capability in-house that's being leveraged. It's just maybe not being leveraged for that particular purpose within the vision. And to that end, typically the answer that comes off the back of the 3 Vs is usually to leverage some form of technology. Now, the problem here in that we've discussed is that these days there's a hell of a lot of acronyms out there. There's lots of various different capabilities. The number of capabilities and platform types is growing daily, it seems, and it can be really difficult for many of our customers to actually understand exactly what they're supposed to do. So for example, Netskope predominantly likely recognizes CASB solution, but actually a lot of the capability it has goes well beyond CASB. Splunk as well, often referred to as logging, but actually a lot of the capabilities that Splunk has goes well beyond just logging. The same for Okta. I'm sure many people are familiar with Okta, but actually there's a huge raft of capabilities that Okta can provide that goes well beyond just simple IAM. Elastic PAM, for example, is one that we're going to look at. And many organizations don't realize that they can actually leverage the technologies that they have to fill gaps simply by addressing and understanding exactly what it is their capability can do and where it maps to a use case, essentially. So we're going to very quickly go over the technologies, and then we're going to have a look at a couple of practical use cases. So from an Okta perspective, I'm very much not an expert when it comes to Okta, but luckily Grace is, so she can talk about Okta for us, and I can tack my bit on the end about Okta.
I was just going to say I'm the warm-up act, so I'm sure that Bears could probably tell you as much about Okta as I can, as he seems to be the font of all knowledge. But I am more than happy to give you guys a overview. So Okta, as Baz has kind of alluded to, is a SaaS identity solution. Now, typically it works in the SSO, IAM and SIAM space, so identity access management and customer identity access management. But it is so much more than that. And that's what we really wanted to bring to everyone's attention today, is really the level of access control it can deliver you through to your APIs and also your on-premise or cloud servers, so that you can make sure that really they are secured and everybody has the correct access and also an easy way of accessing them. If we look at the Verizon report that came out at the back end of last year, most of the successful attacks ultimately ended in trying to get into cloud instances, whether those were Office 365 applications like that, or whether those were actually instances inside of the business's VPC. Now, the reason for that is because it was found to be the most easy place to actually get into, because people were not always aware of the security protocols around it or what they should be doing. And a lot of it is, expectation that the platform that you're using will automate some of that and, put in security groups for you, or potentially, not make it by default public and available on the internet. Now, Okta Identity Cloud has several different modules that allows it to do that. Obviously, single sign-on is a must, but the way that we actually work, which is slightly different to a lot of other products out there, is our universal directory. Now, this allows you to pull in all of your current Active Directory, LDAP, Google for Business, whatever you might be using, Office 365 users, and put them all into one centralized location. This then allows you to map them into their end user accounts for different apps, servers, or anything that they need to access. Literally, the sky is the limit, anything you want to do. Now, we can automate the life cycle of this, so that starters, movers, and leavers process, to really make sure that robustly, when somebody is created, that they're not enabled before their start date or when they first try to sign in. And secondly, when somebody is leaving or moving about a team, that they get the correct access exactly at the time that they should, or in the case of them leaving, that their access is revoked immediately when it should be, rather than, maybe allowing some of those end user accounts and application accounts to kind of linger around. Now, with the advanced server access piece or the API management piece, it's amazing what it can actually provide you in terms of access control, but also allowing things like Netskope to have their rules put in place across your whole estate. And this is how we can really kind of give centralized access at such a scale and make sure that as you are creating new servers, be them cloud or on-premise or a hybrid solution, that we're able to basically provide SSO to your Linux and Windows servers via SSH and RDP, and also across any hybrid or even multi-cloud environments as well. So don't feel like because you might have some AWS, some GCP, some Azure, that you can't use Okta across all three. You definitely can. And there is no kind of additional cost or anything for that, as long as you have the licenses available for the applications. So it's a really, really great way of maintaining that access controls and making sure that that security policy is carried across everything. There's nothing that falls out of it. And also to make it much easier to implement that in a nice, easy to use UI with lots and lots of different granular options around even things like, we'll give people access to this server when they're in the office, but when you're working from home, there's no access available. Now, you can do that using multi-factor authentication as well. So you can ask people for a soft token or hard token or a security question, or even to send them a text message through to their phone. And that way you can deliver out that extra layer of authentication to your cloud servers or your on-prem servers or your hybrid. And of course, to get a lot of value for your developers as well, who might be developing apps on cloud instances now. And they're realistically not an identity provider at the end of the day. They don't wake up every day and think, oh yeah, I really want to make identity. They want to do what they're focused on, which is developing the apps. Whether those are web apps or different types of applications. And so Okta makes it much easier for them and also gives that extra layer of security and kind of just making sure that that is implemented from day one, rather than just kind of putting in authentication or any kind of security at the end of a project. So they can use the SDKs completely free of charge with Okta and implement that and make sure, of course, your business is protected as well.
Fantastic. And actually, when it comes to the developer elements as well, there's an Okta capability that's not on this slide that's new and is one of the ones that we're going to talk about as part of our practical example. So Okta features in both of our examples, but in the latter example, we're talking about advanced server access. So that's kind of a form of elastic PAM where we can take all of these features and from a single sign-on, from adaptive multi-factor authentication. What we can do is dynamically assign users and groups against elastic capabilities or elastic resources that are spun up in IaaS cloud environments on the fly. So that's really cool, and we will talk about that shortly. So from the next capability you have a look at is Splunk. So in particular, this is an element of Splunk which they will be they've announced and have been working on for some time now, which is the Security Operations Suite. But the aspiration here is to make Splunk a kind of single pane of glass collected view for any machine data, so data from anywhere. It doesn't matter whether or not it's from a security perspective, an IT ops perspective, if it's OT or any of those kind of various different capabilities, we want to be able to pull that data in. So and the aspiration here is we're going to pull information in from cloud service providers, and we can actually pull information in from various different cloud management platforms, whether or not that's going to be a CASB or workload protection platform, or even posture management, which many of the kind of CASB capabilities, as they kind of migrate and mature into almost a SaaS capability down the road, will be collectively bundling in, as well as anything that's on premise. As long as it's any machine data, and we pull that into Splunk via either raw events through REST API or other means to give us all of our information in one place. And we can then apply alerting, reporting, and visualizations across that. So that's our Splunk instance. Netskope, again, if you have a look at this, Netskope, as I said, is typically understood to be a CASB solution, but actually it includes various different capabilities. There's the kind of core capabilities at the moment, which is ever expanding. So from next generation secure web gateway, some elements of CASB, so cloud access security broking, also public cloud security, as well as kind of compliance and auditing of public cloud security, which we're going to touch on later as well, which is incredibly important, and even private access. So private access, a form of zero trust essentially, which enables users to be directly connected to the services on premise or servers that they need to directly, without the need to kind of tunnel through an organization via a VPN. Actually, we've seen this leveraged for several interesting use cases above and beyond security very recently, with the advent of remote working, and that's actually to carry out patching. So whereby organizations previously maybe had to be on site to connect to internal servers to be able to upgrade devices and patch devices. There was a real struggle for whole swathes of organizations as soon as they kind of exploded out to remote working, and the VPN concentrators couldn't quite take the traffic of people trying to work and pull these quite large updates through. So we've actually seen Netskope's private access used as a use case to solve that little problem. But as you can see, there's lots of third-party integrations. There's a whole swathe of security microservices, and kind of one of the points that we want to make is that if you kind of understand lingo and you're quite familiar with these technologies, this kind of makes sense. But to lots of customers, this doesn't, because whilst we can understand that, yes, there's a next-gen secure web gateway, yeah, there's some public cloud security, but practically, what does this actually mean? How do we actually leverage that? And again, that's a focus of this webinar, and something that we're going to highlight with practical examples, and that's something that we aim to do by demystifying these technologies to show you practically, step by step, how you would expect them to work with use cases that you would be familiar with and you would care about. Finally, to introduce HashiCorp Terraform. So Terraform is a part of what we call the HashiStack, a suite of various different technologies and tools that all work at various different layers. So HashiCorp works down at the infrastructure layer, and essentially what it is it provides infrastructure as code, software tooling to provide the capability to very, very easily spin up lots and lots of various different cloud resources through infrastructure as code. But the problem is that what it does, it codifies them, as it says, into various different APIs, but it also remembers what it's done. That's the important thing. So as it's starting to build up these various different resources, it will run through various steps in the code, and it can remember what it's done previously and where it got to previously, and can then reference back. So it's an incredibly powerful and incredibly useful capability, and it's something that's used very, very widely across SaaS applications and IaaS platforms to be able to spin up elastic infrastructure as quickly and as efficiently as possible. Okay, so let's have a little look at some of the challenges then. So this is the kind of so what around these technologies. We need to be able to understand what they actually offer from a capability perspective. So our first challenge is today is to have a look at unmanaged devices, or bring your own device. The problem here being is that so my users can download data from my cloud applications to their personal devices. Yep, a use case that we've seen far and wide, especially with the advent of COVID-19 and huge swathes of people working remotely, not necessarily with managed devices. And many organizations who had never worked remotely before, trying to make that leap across into working remotely and expecting their various different personnel to maybe even use their own devices to access it. So how do we have that control around being able to ensure that data, essentially sensitive data, doesn't end up where it shouldn't be, whether or not that's on the end devices or personal devices of our employees, uploaded to unsanctioned cloud applications, or even placed in various different areas within our own organization's storage solutions where they shouldn't be. So, for example, here, if we have a look at, for example, of Office 365 Mail, then anybody, since you can access it from pretty much anywhere, depending on how you've configured your strategy. But if you have no strategy, then you can log on from pretty much anywhere, and then you can download it directly to the device that you're logged into your inbox from. So as you can see here. So the solution is actually to couple two technologies. So you're going to want an IAM solution, such as Okta, and essentially a CASB solution like Netskope. So what we want to be able to do is apply DLP rules across all of our documents and all of our storage areas to say, okay, well, if we're on a fully managed device, that device is completely managed. It has all of the EDR solutions on it. It has all of our AV solutions on it. It maybe has some Netskope element agents on there as well. We want to be, if we're on one of those instances, then we can carry out uploads and we can carry out downloads, because we know that our DLP policies are going to be applied. So what that means is that any unsanctioned applications, any uploads to unsanctioned applications will be stopped. Any downloads from unsanctioned applications or any downloads from sanctioned applications to unsanctioned devices will be stopped. So and the device is managed anyway, so we're comfortable with that. Next might be an unmanaged device. Again, what we do is we don't want to be able to impact people's productivity, but we do definitely want to stop either malware being downloaded to that unmanaged device, or any other kind of DLP instances being downloaded to that. So we may well in this instance want to stop downloads from particular SaaS applications or SaaS application categories and types, but fully allow uploads so that we can maintain productivity. And then if maybe we have some other mobile devices, again, we may want to allow uploads, and we may want to have very specific requirements for download. So if it's on a specific device by a specific individual or a specific individual in the team or from a particular area to another, then we may well allow downloads in that respect as well. It's all completely configurable by leveraging that IAM, so having the identity understood by Okta and then integrating that with Netskope's security control capabilities. So how does that actually work? I know we just talked through it, but let's have a step-by-step example. So we have some end users here, bring your own device, and they're looking to download a file from OneDrive for Business, okay? So the first thing they do as a user on their own personal device is they go to the corporate instance of OneDrive, and they are immediately redirected because we've configured Okta to ensure that anybody who tries to access our corporate instance of OneDrive, they need to authenticate via IAM, and we're going to leverage Okta for that in this instance. So actually, that's going to redirect them straight to Okta. So now that user will authenticate against Okta, and it gives us the advantage of having these additional security controls. So even in the first term, we can have some. We're going to leverage that single sign-on to do the redirect, and then we want to have some adaptive multi-factor authentication as well to ensure that this actually is one of our users. Next, what we're going to do is we're going to do something called a reverse proxy, or a proxy it, depending on the technology. So we'll proxy that through Netskope. So now all of the activity that's being carried out by this user on our OneDrive for Business is being monitored by Netskope. So we don't have to apply any controls. We don't have to be able to block. We don't have to be able to block uploads or downloads, but having some visibility is extremely valuable. So we can find out exactly what was done to our data, exactly where that was. Now, there's some misconceptions around that this can be carried out by any secure web gateway, but typically that's not true because most secure web gateways don't inspect the payloads that are part of the URL. So everything in these days is encoded in the URL. So a OneDrive for Business link essentially looks exactly for one organization essentially looks exactly the same for another organization. So it's almost impossible to infer exactly what happened just by utilizing something like the URI alone. So we have to decode the JSON element in the URI, typically via REST, and then we can pull that information out to find exactly what was done. So we're going to carry out that auditing, and that's real-time software as a service auditing and protection from a Netskope perspective. So now that we've got that auditing, we're going to want to collect all of that into our single pane of glass, because we don't want to have to pivot to various different tools. We don't want to have to swivel chair and log into Okta to find out how that authentication was carried out, and then pivot across into Netskope and see the types of activity that were carried out. We want to have all that information in one place. So we're going to send all the information from Netskope, all the information from Okta, all the way across into Splunk, and then from there we can build out security monitoring views and dashboards. If we've got a SOC, for example, we can also build out elements of alerting and automation. So here we can leverage the technologies of what was VictorOps, but I believe now it's called Splunk on Call, and Phantom. And what Phantom will do for us as a source solution is it's going to automate a response based on the logs that we're pulling in from and the information that we're pulling in from the activity that's being carried out by this user through Okta, and then from Netskope's auditing perspective. And what Splunk on Call or VictorOps then is going to do is ensure that based on our security monitoring and whatever alerting we've configured in the Splunk Security Operations Suite, that the right person is contacted and told about this type of activity. So in this instance, we're going to inform them that, okay, a user has attempted to access OneDrive for Business. They attempted to access it directly on their personal device. We've redirected them through Okta, and now they're being monitored via Netskope. What do you want to do? What we may also want to do actually is, because this happens so often, maybe this is a large organization and we already have some security control process in place to mitigate against these, we might want to automatically respond. So in this instance, we might say, okay, well, what we might do is we may well disable that user's account if they've reached, if they've ticked the right boxes from a suspicious activity perspective. Or maybe we, from an Okta perspective, what we can do is we can either disable their access to just one particular service. So we may just block them from accessing OneDrive for Business, but enable them to continue their productivity on other services, or we may well block them from all. Again, we have the flexibility and options to be able to do that from our SOAR platform perspective. And then lastly, we want to educate. So ultimately, we want to educate our users to say, okay, well, you shouldn't be downloading things from OneDrive to your personal device. And if you do access OneDrive from your personal devices, you're expected to authenticate via Okta, etc. And we can explain the reasoning why, which is ultimately going to be one of the best security controls, is to ensure that people are on board and that they understand why things are done. Ultimately, yeah, people are a huge influence on that. Okay, let's have a look at one more problem with a slightly different twist. So this time we're going to have a look at this cloud DevOps. So I mentioned it briefly previously that within a development environment, certainly within a cloud development environment, whether or not that's AWS, whether or not that's GCP, Azure, but virtual resources are often spun up, cloud resources are actually spun up at great pace. Typically, they're not spun up in isolation. So if an EC2 instance is created, it's going to need, for example, a VPC. So it's going to need some sort of networking to be able to communicate with other EC2 instances or the internet. That's going to be associated with lots of security rules. And there's lots and lots of moving parts. So when we spin up an EC2 instance, actually there's myriad of various different resources that are bundled around that EC2 instance typically. And these can be spun up and destroyed in minutes or seconds, especially if we're leveraging elasticity in the cloud, and we're also leveraging things like Terraform to be able to really, really quickly build out these instances for us. So you can imagine having a look at that dynamic environment. It is completely a moving target. As I mentioned previously, it's extremely transient, ephemeral by nature, and we need it to be elastic. That's one of the major advantages of cloud computing. And because of this, that means that the attack surface is constantly in a state of flux. If we have no or very few S3 buckets, that attack surface is smaller. But if for instance, our web service has a huge influx of users and we need to expand elastically, we may spin up more EC2 instances. Those EC2 instances require S3 buckets to be able to put some information into. And then our attack surface has now just grown. Give it a few hours and the rush is over and it will reduce back down. So it's constantly shifting. And there is no boundary to it. Again, within a development environment, so if we're in an environment which is specifically for kind of development, but this works from a cloud ops perspective as well, they'll typically still use shared default admin credentials when you first spin them up. So you'll be given some methodology to access the box. However, it's typically going to be, the username is still going to be admin, and it's the password may change, or you may well be logging on hopefully via certificates. However, that's not necessarily always the case, but typically the user is the same. And this poses a problem because everybody kind of knows who those usernames are, so they can attempt to make cracks against those passwords, whether or not that's through accessing EC2 instances that have been exposed to the internet indirectly, or other means. The other bad thing is that it's difficult then to audit the instance, because if everybody's logging in as the admin instance, we don't really know who that is, because typically once an EC2 instance is spun up, although there are different capabilities and methodologies for securely accessing those, such as Bastion Host, when we look at the logging, it's still typically the admin user that's being logged onto, unless you go and specifically set up each EC2 instance, which is kind of against the nature of elasticity and why we would use Terraform in that instance. And again, extremely favored by the development. It's quick, they're known, and they're difficult to audit those credentials. So it's kind of like a game of whack-a-mole, right? So there's always various different EC2 or resources that might be spinning up. And by the time you've maybe cast your lens across to have a look at it or applied some sort of security control to put that in place, it could have reduced in size. So it's quite difficult and therefore takes up a lot of resource when it comes to human input. So if we have a look at a solution here and kind of have a step through that. So this is leveraging Terraform. So that's our infrastructure as code. We're also going to leverage advanced server access, as I mentioned. Which is advanced server access IAM, but it's almost like an elastic PAM essentially, as well as cloud compliance and auditing from a Netskope perspective chucked in at the end. So the way that this works is, and this is actually an example of Splunk Cloud. So Splunk, the organization, how they manage their cloud instances. They utilize this methodology. So, for example, we have a new customer. Let's stick with that use case. We have a new customer, and we need to build a completely new cloud instance for that customer. And once we've built that new cloud instance, we need to then enable our development team and various other elements of our team to be able to access those instances in a secure way so that they can start to set up and configure and test ultimately before providing access to the customer. So here what we do is we configure this elasticity, we configure this build via Terraform. So we're going to build ourselves a Terraform script. We're going to build ourselves some instruction as part of the infrastructure as code. And what Terraform will then do is two things in parallel. So from a IaaS perspective, so we're going to look at AWS in this perspective, it will go ahead and create us a VPC. So this is going to be the networking layer that all of our EC2 instances are going to communicate upon. Then it's going to go ahead and start to spin up those EC2 instances, again, configuring them as per Terraform has been configured, its infrastructure as code configuration deems it to be. And then finally, what it will do, it will enroll the instances with what's called an advanced server access project. At the same time, Okta ASA is going to create an ASA project, again, informed by Terraform's infrastructure as code. It will then assign groups of known groups of users and known identities within Okta into those groups, and then it will generate enrollment tokens for those. And then it will communicate with AWS to enroll that ASA project and have those tokens enrolled. So what this means is that dynamically, as instances are built, either wholesale, as in this example, or elastically through configuration of Terraform, as soon as that instance is built, people can, the dev team and various other elements of the team can access that using their IAM credentials. So we don't have to rely upon these kind of initial admin passwords. We don't have to rely upon things like Bastion Host, which I'm not recommended we leverage anymore. You can just log on like you would any other IaaS solution, any other SaaS solution via Okta, and then you can RDP or SSH straight onto the box, straight onto the EC2 instance, for example, and continue to work as if you were the admin. However, now we have all of the controls that Okta has around it, so we can only give access to those instances as soon as the project starts, and when the project is removed, we can revoke it, which actually is a good thing, because it means we can rapidly assign, based on their Okta identity, people access to elastic instances, as opposed to trying to have to figure out exactly which instances are. Maybe we have to change the Terraform code. Maybe we have to give them access to a completely new user. And that can slow the process down. I've certainly been at sites where in cloud environments, it can be really difficult to set up in an ad hoc manner access to some of these cloud instances, whereas the problem goes away if we use ASA. So actually devs are on board because they can start work much more quickly, as well as being able to remove access to these servers. And last but not least, we can audit everything. We have everything auditable. And as per the previous example, we would typically be funneling that into a data from anywhere platform so that everything is nice and succinctly in one place. And we have full visibility from an auditing capability as well. So if we couple that belt and braces with Netskope and its capability to carry out public cloud security auditing from a compliance perspective, then this is really going to ensure that happens. So we have Terraform, we've configured our infrastructure as code, we've configured our AWS instance in this example to talk to Okta's ASA instance and configure everything securely. And then what Netskope is going to do is ensure that all of those instances that have been built by Terraform are compliant, as we would expect them to be. It can do that via custom rules. It can do it via rules for various different compliance capabilities out of the box. So, for example, best practice from the best practice perspective with AWS, maybe it's against the NIST standards. So it can tell us exactly how many rules have passed and how many rules have failed. And what this will do is give us that visibility. It will give us the visibility of where there are gaps in our cloud security, essentially. Are there any EC2 instances that have been configured that we didn't expect? Have they not had the right security policies applied to them? Maybe they weren't included as part of the ASA, the Okta ASA rollout, because they were rolled out via a different Terraform element, or maybe they were built elsewhere. So, and again, from an overview perspective, AWS accounts, Azure subscriptions, again, it's going to carry out a complete inventory for us on all of those things. So the solution there then is to integrate your IAM platform elastically across your cloud estate, leverage the IAM solution. It is agile and your infrastructure is agile, and they're as agile as each other, so they can keep up. We're going to expand our security footprint as the attack surface expands. So as it expands, our visibility and our visibility and footprint expands along with it. We're going to ditch default credentials and start to embrace identity in everything that we do. So it's very well embraced from an IaaS perspective already, certainly from the management plane, from people accessing the console, definitely from a SaaS perspective, but it's not quite well embraced at the moment from the actual resource access. So, SSH or RDPing onto these instances. And this ultimately helps us keep devs on side because they have seamless automated access. So we completely streamline the process, and it might still very well be a game of whack-a-mole, but we have the capability to be able to keep up with it with less resource. So ultimately, it's pretty dangerous to go alone out there in this ephemeral cloud environment. So we want to be taking the various different technologies and getting them to work together for us. So as mentioned, these technologies are pretty good on their own. They're usually best in class. Certainly the ones that we've used as our examples today, but actually they work so much better together. And what we want to do is ultimately sweat that asset. Typically lots of these cloud security solutions can be expensive, and what we want to do is make sure we get every single drop of value out of them as possible. And if that means that there are various integrations between maybe some of those siloed capabilities that have not been leveraged already, then it's absolutely worth the effort to integrate them and leverage that. And this can, in the instance of as that we saw there from a Terraform perspective, we're building our infrastructure as code, but afterwards we maybe want to belt and braces that have that assurance that actually all of our policies work set correctly as we expected them, not only from our own perspective, but also we can prove it from an auditing perspective. From an integration and interoperability perspective, the technologies and the platforms are really important, but actually the first most important point is around people and process. So if we understand the people and the process around each of the various different technologies, and we can typically get that by assessing our vision and understanding what our vision is and applying whatever requirements we need for visibility for that, we'll then be able to understand where we want to be from a value perspective so that we can ensure that the right people and the right processes are in place to help support the technologies. One of the major downfalls that we see with a lot of these with a lot of these cloud technologies certainly is that whilst they may be incumbent in place and leveraged to an extent, there's typically no people and process policies applied around that. So whether or not that's from a target operating model or various different elements of best practice around those as well. And ultimately, we want to foster those symbiotic relationships. So typically, it might not be one way. With Splunk, for example, typically it's seen as one way. Splunk takes in the logs and it does what it does. But actually, Splunk could feed things back out through adaptive responses via ES or through alert actions as well from non-ES search heads. So it can actually integrate and carry out activities and actions on other platforms as well. So it's not just a one-way street. And yeah, forward thinking, right? So if we're embracing and adopting cloud technologies, threats in the cloud, as it says, require in-cloud solutions. This is typically due to lots of cloud adoption, certainly over the last year, that has been taken at pace by many organizations who've been striving to remain relevant and provide output. Cloud adoption has massively increased. And this is something that we've seen with many of our customers, and actually trying to demystify that, trying to understand what is their actual capability, what is their vision, how do they want to, what is it that they need to protect and they want to protect, and how can we help them understand and get to the point where they're producing value from that, and actually all of their controls and requirements from their vision are met. So yeah, that's what, as it says at the bottom, a disruptive but an honest approach. Because if you go and Google CASB, you go and Google Secure Web Gateway, you go and Google Cloud IAM, you're going to be hit with screens and screens and screens of marketing, and it can be really difficult to understand what that actually means. So this is why we're taking our time to go through the process of trying to not just provide use cases, but show how those use cases would work through the integrations and where each of those technologies takes place. So we mentioned HashiCorp. Had various different technologies in what they call the Hashi stack. Vault and Console, for example, we didn't mention during this webinar, but we did mention Terraform, as well as the various, as well as Netskope, Okta, and Splunk. So there are some other elements that we're going to include later on as we start to build upon Vault and Console. But essentially, these are our capabilities, and this is what we'd like to call our security solutions ecosystem. So typically all best of breed, all with various different symbiotic relationships as opposed to typically one way, and they all integrate extremely nicely. Okta has very many different applications that leverage Splunk, and Splunk has pretty much applications for every single one of these on screen. Netskope integrates very nicely with many of these as well. So that's typically our approach, is to take these technologies and get more value by getting them to work together. Okie dokie, right. That was the webinar. So if there's any questions or queries, feel free to shout them out now. If you feel more comfortable sending them afterward, absolutely please do send them through to the email addresses that should have been sending correspondence out with regards to the web pages through marketing, or you can contact us through the website as well. Thank you for listening, and have a fantastic rest of your afternoon.